So we're going to do the spring 2015 test today. And I'll go as fast as you let me. If you want to ask questions, please do. So number one, using interval notation, identify the solution to the rational inequality. X minus 20 over x squared plus 1. And that's got to be greater than or equal to 0. So we can divide the domain into all of its pieces and then figure out which of those pieces satisfy the inequality. So, is this undefined in any area, for any points? So we need to check to see if the denominator equals 0. Does the denominator ever equal 0? X squared plus 1 has imaginary roots. It never equals 0 in the real numbers. So we don't have to worry about that. Do we ever square root a negative number? No. So now all we need to make sure is that the answers, so the top, if the top is positive and the bottom is negative, then it will be less than 0. If the top is positive and the bottom is positive, then it will be greater than 0. If the top is negative and the bottom is positive, then it will be less than 0. Does that make sense? So either the top and the bottom have the same sign, or they have opposite signs. Does that make sense? If the top and the bottom have the same sign, then this is true. And the bottom can never be negative, so we're getting there. So as long as the top is not negative or equal to, right. So as long as this is 20 or bigger, then the fraction will be greater than 0, because there's no way for the bottom to be negative. Now, what's another way you could figure this out? You could graph it, but x greater than or equal to 20, that's going to be hard to see. You'll have to change your window. But you're just looking for where the graph is less than 0. So the root of this, right, if I set this equal to 0, x equals 20 is a root. So everything everything to the right of 20. So you could graph it and just see where is it above the x-axis, but you'll have to change your window in order to see it. Yeah, always graph it. Yeah, you have plenty of time. If you get an answer, graph it, just to double check. So the answer was B. Is that? Hey, we're 1 for 1. Find the domain of square root of x over x minus 15. So we know x is not allowed to be 15 because that makes the bottom 0, which turns it into infinity or negative infinity, depending on what direction you're coming from. And x has to be greater than or equal to 0. So in interval notation, it would be from 0 to 15, and then from union, do they do union? Union with 15 to infinity, which is D. Did we get it right? Yeah, we're on fire. Using interval notation, determine the range of the function. Okay, the domain would be, the domain has to be anything from -10 up. Okay, so what about the range? So this graph starts here. What does the x plus 10 do? Moves it left 10. What does the negative 20 do? Makes it down 20. So from negative 20 to infinity, that's the range. Or, if you were really excited about this problem, you could find the inverse and look at the domain. because the domain of the inverse is the range of the original and vice versa. Okay? Yeah, I wouldn't do it that way. Number 4, starting with x squared, you want to transform x by shifting horizontally 4 units to the right, vertically stretch the graph by a factor of 2, and reflect the graph across the x-axis. So I have x, and I'm going to square it. How do I move left 4, or right 4? So subtract 4. How do I do a vertical stretch? Times it by 2 where? Outside. Timesing it by 2 on the inside would be a horizontal shrink, because everything inside works backwards. So timesing by 2 on the outside will make it twice as tall. Timesing by 2 on the inside will make it twice as narrow, which is about the same thing. They're not exactly the same, but they're close. Sometimes they are the same, but very rarely. So 2 out here, and reflect across the x-axis, negative on the outside, because the outside affects the y's, and if I turn all the positive y's to negative y's, or vice versa, that is the answer, which is C. That's good news. All right, number 5. The square root of x minus 10 is 1 to 1. What does 1 to 1 mean? 1x for every 1y. It passes both the vertical line test, so it's a function, and the horizontal line test, which means it's invertible. Find the domain of the inverse. Well, it would be a lot easier to just find the range of the original. And my parent function is here, but I move to the 10. I move 10 to the right. The range is from 0 to infinity. We want the domain of the inverse, which is the range of the original. So instead of inverting it, we're just going to find the range of the original. Now, inverting it is a little bit of a problem, because you get x squared plus 10, and x squared plus 10 is defined everywhere, right? So why is the answer not all real numbers? This, oh, it's actually up here. This piece here is the reflection of this piece here. So the inverse function actually has both halves, whereas the original function only had one half. So there is, remember, plus or minus. The other side of this would be the negative version. So you have to be a little bit careful with inverses. It's a lot easier to just find the range of the original than it is to invert and then find the domain. 6. Given x squared plus 1 and square root of x minus 3, evaluate f of g of 0. Now I could plug g into f, but it would be easier to plug 0 into g, and we get the square root of 0 minus 3. So the square root of 0 minus 3 does not exist. So the answer is E. Now, if we compose the functions, so let's say I put the square root of x minus 3 inside x squared plus 1, I now get x minus 3 plus 1, which is x minus 2. And if I plug 0 in there, I get negative 2. But that answer is not right, because the original g had a domain restriction that 0 was not part of. That seems like something they like to do a lot. Number 7. Which of the following statements is true concerning the graph of the rational function? 100x squared over x squared plus 10x. First off, does this have a horizontal asymptote, a slant? It has a horizontal. Is it at 0? No. In order to be at 0, the degree of the bottom has to be larger than the degree of the top. But in this case, the degrees are equal. So we just take the two leading terms and divide them, and I get x squareds cancel, and I get 100. So the horizontal asymptote is at 100. Does this have any holes? Well, if I factored out an x, then this is going to cancel that. So there is a hole at 0, x equals 0. And it has a vertical asymptote. Where's the vertical asymptote? -10. So the denominator has two roots, x equals 0 and x equals -10. The x portion of that canceled, which means there's a hole. And this factor did not cancel, which means it's a vertical asymptote, and we have a horizontal asymptote at 100. Okay. A, the graph has a slant asymptote. No. As x approaches infinity, f of x approaches 100. Yes, that's the horizontal asymptote. It's also true that as x approaches negative infinity, then the graph approaches 100. The domain of the function is given as negative infinity to -10 union with -10 to infinity. There's one problem with that. 0 is also a discontinuity. D, the graph has two vertical asymptotes. 0 is not a vertical asymptote. It's a hole, so the answer would be B. We got them all right so far? Number 8, the monthly profit that a drug company makes for the production and sale of X kilograms of a painkiller is given by the quadratic function from 0 to 300. I like it when they do that. What is the maximum profit the company can achieve? So your best option would be to graph it. -1.25. Oh, shoot. X squared plus 300x minus 2000. And they gave us an X window, which is nice. Then we do zoom 0. I messed up. That can't be right. -1.25 x squared plus 300x. So zoom. Did I mess up again? I'll get it right. So it should be, oh, that's right. All right, so I know the window is from 0 to 300. So if you know what the window is, when you do maximum, you can just type in, 1 and 299, and it looks like the answer is going to be about 120. You guys impressed? I got it. It's 120, 16,000. So the maximum profit is 16,000. So at 120 kilograms of painkillers, they make a profit of 16,000. I don't know. That's got to be it. I'm sure that's it. Okay, number 9. X equals 1 is a 0 of multiplicity 2 of the polynomial function, that quartic. Which of the following is a linear factor of that function? So what's the best way to simplify that? We could do synthetic division twice, which is probably easier, or we could take x squared minus 2x plus 1 and do long division once. But synthetic division is probably easier. So 1. Okay, really slow. Okay, those are the coefficients. You need to make sure we're not missing any of the terms. So if you look at the function x squared, x to the third, x to the fourth, x to the third, x squared, x, and constant. So now, that way, we don't have to put any placeholder zeros. So I drop the first term, 1 times 1. So I multiply these together and write the answer here. And then I just do whatever it says. Negative 2, positive 1 makes negative 1. Then we take our 1 and we multiply it by negative 1. 2 minus 1 is 1. Wait a minute. Oh, I didn't see that 1. So 1, this is negative 1. 1 times negative 1 is negative 1 and 0. Now I knew it was going to be 0 because they told me that x equals 1 is a root. Now I do it again because it had a multiplicity of 2, and the answer for this should also be 0. So 1, drop this 1 here. 1 times 1 is 1. That's 0. 0, 1, 1, 0. Oh, I just put that in the wrong place. I'll get this figured out, guys. There we go. So I'm left with x squared plus 1, which has the complex conjugates as its linear factors. So the answer is x equals plus or minus I. Those are the roots, but it wants a linear factor. So x plus I and x minus I. So if any of those show up, that would be the answer. So A. What if it gets down to like x squared 4x plus 1? How would you find the imaginary? How would you find the complex linear factors? You'd have to use the quadratic formula and then turn it into a factor. So if you use the quadratic formula and you get 4 plus or minus 6i, then it would be x minus 4 plus 6i, or x minus 4 minus 6i. Hopefully they don't do that to you. Okay, number 10, x plus 3 is a factor. Which of the following is a 0 of the function? Synthetic division using what number? Negative 3. Synthetic division relies on the root. And they gave us the factor of x plus 3. And are we missing any terms? No. So 1, 3, negative 2, and negative 6. So we drop the 1. Negative 3 times 1 is negative 3. We get a 0. Negative 3 times 0 is 0. Negative 2. Negative 2 times negative 3 is 6. So we end up with x squared minus 2. So there are two ways to do this. You can either factor it into conjugates, which would be x plus minus and then square root 2 square root 2, or you can set it equal to 0 and add 2. X squared equals 2, so x equals plus or minus the square root of 2. Do I need to plug these answers back in? When do you need to plug them in? If it's a logarithm or if it's a square root problem. Okay? And also, if you're dealing with rational expressions, you need to make sure that the denominator is not 0, but that also didn't happen. Number 11. C. Yes. A third degree polynomial function has a non-zero constant and no variation in sign. So a third degree polynomial would be x to the third, x squared, x, and a constant. Okay? And it has no variation in sign. They're either all positive or they're all negative. Okay? And we know that the constant is not 0. If the constant is 0, then we know that one of the roots is 0. So the statement f of x must have at least one negative real number among its zeros. So does it matter if we do all pluses or all minuses? No. So let's just do all pluses. So this is f of x. So f of negative x would look like negative, positive, negative, positive. So this has no changes. So if we did our chart, positive, negative, complex, positive is 0, but negative would be, so here's a sign change, here's a sign change, and here's a sign change. So this is 3. So the chart would be 0, 3, 0, or 0, 1, 2. So f of x must have at least one negative real number among its zeros. True. Now what if this was an x to the fourth, and that was a 4? Then the other option would be 0, 2, 2, or 0, 0, 4. Now the answer would be false, because it is possible that all 4 roots are imaginary or irrational or imaginary. Now, if we would have thought about this in a different way, we could have answered it without doing any work at all. Okay? It's an x to the third. Does an x to the third have at least one root? Yes. Why? So this is an even. That's an odd. Evens can miss everywhere, but odds have to hit at least once. And the original function had no sign change, and the constant is not 0. So we are guaranteed there are no positive roots. We're guaranteed that 0 is not a root, and it's an x to the third, so it has to hit once. If it doesn't hit positive or it doesn't hit 0, it has to hit negative. So you could have figured that one out without doing any work at all, without writing anything down. But I didn't even think about that. Okay, where are we? 12? So negative 3 e to the x plus 4 equals negative 15. We're going to natural log, but not yet. Divide by negative 3. So e to the x plus 4 equals 5. Natural log both sides and drop the x plus 4. The ln of e is 1. So I get x equals the ln of 5. And then we're going to subtract 4 from that. So B. $13. The ln of 2 over x plus the ln of x minus the ln of 2. Well, you can't factor out natural logs because it's not multiplied. We have to use the product and quotient rules. So anything positive ends up on top, anything negative ends up on bottom. So we get the ln of 2 over x times x times, well, 1/2 or over 2 And I get the ln of 1. What is the ln of 1? 0. Okay, there's another way to do this. What if we use the quotient rule and go backwards? What would that be going backwards with the quotient rule? It would be the ln of 2 minus the ln of x, and we already have plus ln of x minus the ln of 2. Everything goes away. So either way you do it, you're going to end up with 0. Okay, 14. 2 ln of x minus 3 equals 4. We have to do one of two things to start with. Divide by 2, or I could also move that 2 to an exponent. Which one makes more sense? Dividing by 2. What's the problem with moving the 2 up to the exponent? Then our answer is going to have a plus or minus in it, and one of them isn't going to work because we're going to end up squaring a negative. Well, one of them might not work. I guess if they're both bigger than 3, it won't matter. So if you move that 2 up here, it will work if there's an answer, but chances are one of those roots is going to go away because this really only has one answer, but you'll be creating a second when you do that. So divide by 2, ln of x times x minus 3 equals 2. What do we do from here? Nope. We convert to exponent. So this is base e. So e squared equals x minus 3. So e squared is a number. So e squared plus 3 equals x. Now I need to make sure that when I plug that back in, I don't natural log a negative number. E squared is a positive number, plus 3 is a bigger positive number. So if I stick that in and subtract it, do I create a negative? No. So E. And if you would have done it the other way, you would have gotten probably C, but one of those, the 3 minus E squared, will create a negative number. So you'd have to throw it out. 15. 2 log base 2 of x minus log base 2 of 3 equals 1. What do we want to do here? We got to move the 2 up to an exponent. Is that going to cause problems? Yes. Because if x is negative and we square it, then it's doable, but the original problem did not have the square up there. So we'll have to double check our answers in the end. And then we use the quotient rule. Log base 2 of x squared over 3 is equal to 1. So 2 to the first equals x squared over 3. So I multiply by 3. I get x squared equals 6. So x is equal to plus or minus the square root of 6, but in the original problem, the negatives were not allowed. Because if I plug a negative in there, then it's you can't take the log of a negative number. But by moving that 2 up, I allowed that negative, so you got to get rid of it. So the answer is D. Wow, I'm surprised they didn't. I'm surprised one of the answers isn't plus or minus 6. Oh well. 16. E to the 2x plus 4 e to the x equals 0. What would you do here? U substitution. So u is equal to e to the x. So this would be u squared plus 4u equals 0. So we get u equals 0 and u plus 4 equals 0. Now each of those is equal to e to the x. Well, sorry, u equals -4. So e to the x equals 0, and e to the x equals -4. Now e is a positive number. Can you take a positive number and hit it with an exponent and turn it into 0? No. All exponential graphs look either like this or like that. Where do they hit the x-axis? Never. So this one does not exist. What about the other one? E is a positive number. Can you use exponents to turn it into a negative number? No. So this one doesn't exist. So no solution. The graph of a logarithm is the inverse of an exponential graph. So exponential graphs either look like this or like this. You cannot make negative numbers using exponents. They're not in the range. A logarithm graph is the inverse of that. So it either looks like this or like this. You can't use negative numbers in logarithms because exponents cannot create negative numbers. So negative numbers are not in the range of exponents. Well, exponents and logarithms are inverses, so negative numbers cannot be in the domain of logarithms. So the exponential graphs are never below the x-axis, and the logarithm graphs are never to the left of the y-axis. You just can't take a negative number. So if I had log base 2 of -4 equals what? That's the same as saying 2 to the x equals -4. It can't happen. You can't take a positive number and use multiplication of itself and create -4. So this doesn't exist because it can't be below the x-axis. And this doesn't exist because it can't be left of the y-axis. All right, where are we? 17? E dx is to be transformed by reflecting across the y-axis, shifting down 15. So how do we reflect across the y-axis? Negative x. We're changing the x values. The positive x's are going to be negative x's and vice versa. So that would do it. And how do we go down? 15 units down. Subtract 15 on the outside, which is E. In the partial fraction decomposition of 5x over x squared minus x minus 6, what is the numerator of the x plus 2 term? So x minus 3 and x plus 2, how many partial fractions am I going to have? Just 2. So it will be a over x minus 3 plus b over x plus 2. This needs an x plus 2, and that needs an x minus 3. Everybody get that? Everybody remember why that's the case? So we end up with ax plus 2a plus bx minus 3b is equal to 5x, and it might be a good idea to put plus 0. So now I just group all of the x's and all of the constants. So this and that turns into a plus b equals 5. You could write the x's, but we don't need them. Once we have them distributed into the correct row, we don't need the variables anymore. And then 2a minus 3b is equal to 0. So 2a minus 3b equals 0. You solve that however you want. Anybody get the RREF yet? So you end up with, so A is 3 and B is 2, and it wants the x plus 2 term, so it wants this one, which is 2. Okay, 19, consider the following nonlinear system. You could graph this. The trouble with graphing it is, the bottom one is a circle, so you're going to get a plus, the positive square root of 16 minus x squared, and the negative square root of 16 minus x squared. Probably not worth it. It's probably easier just to use substitution. So x equals y plus 4, and I'm going to substitute that in here. So I get y plus 4 squared plus y squared equals 16. You guys follow so far? So we should be really good at multiplying these by now. Y squared plus 8y plus 16 plus y squared. Then I need to subtract this over. Minus 16. That's nice. So 2y squared plus 8y equals 0. What should we do there? Take out a 2y. So 2y times y plus 4. What are the roots? 0 and negative 4. Those are the possible y values. What are the associated x values? Oh, we're done. Okay. Who cares? So the answer is B. You could have put it in your calculator and then you would have gotten, so it's going to be a circle and a line that looks like this. And you just need the y value. You'd have to find both intersections and then the y values of those intersections. So it's probably actually right here. There's the 0 y value and there's the negative 4 y value. Yeah. I guess we could have figured it out by looking at it, right? That circle goes over to 4. It goes to negative 4 and it goes down to negative 4. And then the equation is y equals negative x plus 4 or minus 4. So it's got to hit the y-axis at negative 4, and it has a slope of negative 1. I wouldn't have thought of that. Number 20. So you're just going to plug that into your RREF. Make sure that the missing terms get a 0. And what do you get? Do you get a so if you get this, then this will be your x, your y, and your z answer, but apparently you don't. On the bottom row you have, which means no solutions. What if it was 0, 0, 0, 0? Infinite solutions. What if the middle one was no solution and the bottom one was infinite solutions? That would be no solution. That's like saying we have 2 copies of the floor. We have 2 planes that are identical. So those 2 touch everywhere. Where do those 2 touch the ceiling? Nowhere. Provided you build your buildings correctly. So that one would be no solution. Okay. I'm going to simplify the equation on number 1 to y equals PE to the negative RT. After 2 months, the value of the copier is assumed to be 49,000. So 49,000 equals PE. Does it say? Oh, it started at 50. So 50,000 E to the negative R times 2. So we can use this to find the rate. So I'm going to divide. I get 49 over 50 equals E to the negative 2R. ln both sides. Drop the negative 2R. This goes away. So what am I going to do to ln of 49 over 50? Divide it by negative 2. I went really fast. Does everybody get that? Where'd you get lost, Dave? You get it? So the ln, ln of 49 over 50, and then I divide that by negative 2. So the copier is losing 1%. And you might, I don't really care, 1.01%. Okay, so that's the answer for A. Letter B. Another department has also purchased a new but different copier, and the value will also be predicted using an exponential decay model. They have decided to use a decay constant of 0.015, which is 1.5%. So this one dies, this one loses value quicker. The department reports that 6 months after purchase, the value of the copier is 40,000. Determine the initial value. So 40,000 equals P times E to the negative 0.015 times 6. How do we solve for P? Just divide by E to the all of that. So 40,000 divided by E to the negative 0.015 times 6. Now, if you have the old software, you need to make sure that those exponents have parentheses around it. $43,766.97. Oh, number 2 is identical to the one we did yesterday, right? Maybe it will be. Do you guys want to see it? So we have R of t equals the square root of 100 over t plus 1. And A of R is pi r squared. And it said, so this is this is a cancerous mole, and we're hitting it with chemotherapy to shrink it. So the size of the mole over time, and this is in days, right? Changing over time in days. So the size of the mole in days is the square root of 100 over t plus 1, and the area of the mole is pi r squared. So it wants us to compose the two functions and create a function that will give us the area versus time, the area given time. So we want to compose the two, so we have to stick this in here. We can't really compose it the other way, because if we tried to plug it in the other way, there's no t in the bottom equation. It just doesn't work. So we get pi times the square root of 100 over t plus 1 squared. Oh, sorry, this square root goes all the way down. So the square roots just cancel, And we get 100t over t plus 1. Oh, that's what I meant. I said t, but it's a pi. So that is the function that will tell us the size of the mole given time. So you plug in 1 day or 2 days or 3 days. Number 8 says when the mole reaches 20 square millimeters. Oh, this is different than yesterday. It was 50 yesterday. So we want to know, when does this equal 20? So I cross multiply 100 pi equals 20t plus 1. So it'll be 100 pi minus plus 20. Thank you. Minus, so 100t minus 20 over 20. So that would be 50 pi minus 1. Round your answer to 1 decimal place. So 50 pi minus 1. It's going to take 156 days. Uh-oh. Uh-oh. Oh, it's 2. How about 5? 5 pi minus 1. There we go. 14.7 days. Glad Shem's here. Hand it in. 3. Due to a decrease in demand, a small production facility that bottles pure mountain water is cutting back on the number of gallons it ships each day. After X days, the number of gallons will be approximated by that model. Find the inverse. So our original function is y equals 2,000 over x plus 1,200. If we want the inverse, x equals 2,000 over y plus 1,200. So if I solve for y, I get x minus 1,200 equals 2,000 over y. The slow way to do this would be times by y and then divide by x minus 1 minus 1,200. The fast way to do it is just to switch these. Y equals 2,000 over x minus 1,200. Letter B, the range of the inverse. Well, it's the domain of the original. Does the domain, so if we go back to y equals 2,000 over x plus 1,200, does the domain have any restrictions? Careful. It's between 1 and 200. How do I know that? It's in the original problem. So they told us this function is only valid between 1 day and 200 days. So the range oh, how nice of them to tell you, no work required. So this is the original domain, which must be the range of the inverse. Okay? Letter C, in the context of this problem, what does the input x to the inverse represent? So it's saying when I plug in x's, what numbers am I plugging in? What are the units on x in the inverse function? Well, What's the unit on y in the original function? So x is days in the original, and n is gallons of water. So in the inverse, x represents gallons of water, of pure mountain water. Gallons of pure mountain water. Did it want the y? It just wanted the x. Number 4, a patient is given a shot of a drug into the shoulder muscle. The amount A of the drug in the patient's bloodstream at a time t hours after the injection is predicted using the model. So y equals 150t plus 100 over t squared plus 4. Note, this is a rational function. Oh, thanks. Provide appropriate units below. When the amount is at least 50 milligrams, the patient receives a medicinal effect from the drug. According to this model, when will the amount of the drug in the patient's bloodstream first reach a value of 50? You could graph it, and hopefully it's a nice number. Let's try graphing it, see what happens. So 150x plus 100 divided by x squared plus 4. So if I looked at my table, so when does it first hit 50? At 1 hour. Okay, so, well, maybe I did. So, this is a really great drug. How long is it effective? For an hour. It's only effective, for the first hour it's not effective. For the next hour it is effective. And then it's not effective again ever. So in the long run, what will the value of the amount of the drug approach? Well, 0, right? I don't even need the equation for that. But looking at the equation, how do you know it's going to be 0? Well, mathematically, why is it 0? No. Well, right. So it's saying you can't go back in time and look at the, you can't go back in time and look how much drug there was in his system before the injection occurred. So look at the equation. How do you know that as we go to the right, it's going to approach 0? Right, there are more t's in the bottom than there are on the top, so the horizontal asymptote is 0. But I guess if we were injecting mercury, it wouldn't approach 0, because some mercury sticks around forever, right? But okay. Oh, your favorite problem. A rancher has 2,400 feet of fencing and wants to enclose a rectangular field along a river. There will be no fencing required along the river. The width of the rectangle is denoted by x. Hey, and who said the river was straight? What if the river was curved? Right? Anything can happen. So that's x. That's x. What is the top portion of the fence going to be? 1,200 minus 2x. Oh, is that what it is? 2,400? Shem, you know, you redeemed me a little while ago, and now you've ruined it. So the area is going to be x times 2,400 minus 2x, which is negative 2x squared plus 2400. 2400x. Thank you. So that is the area. All right. How are we going to find the maximum area? Graph it. I don't have time to graph it. The roots are 0 and 1200. So it must occur at 600 feet. If you plug in 600 feet into there, you should get it. But just graph it. Find the maximum area. It's the average of the two roots. Okay. We've got